Yeah, good evening, children. Good evening. Yeah. So continuing with the quadrilaterals, exercise 8.2, question number 5. So here in a parallelogram ABCD, what are you writing? Yeah. Look at the screen. In a parallelogram ABCD, E and F are the midpoints. E and F are the midpoints of the sides AB and CD, respectively. Are you writing the question? No, wait. We'll understand the answer. I'll give you time to write. Okay, ABCD is a parallelogram. E is the midpoint of AB. F is the midpoint of CD. We need to show that the line segments AF and EC, line segments AF and EC, they trisect the diagonal BD. This is the diagonal BD. Trisect the diagonal BD meaning cut the diagonal BD into 3 equal parts. Bisect us into 2 equal parts. Trisect us 3 equal parts. Bisect, trisect, 3 equal parts. So you need to show that DP is equal to PQ is equal to QB. This is the diagonal BD. This is the diagonal BD. You need to prove that the diagonal BD is trisected. Okay. And the 3 parts, the 3 equal parts, DP, PQ, and BQ. You need to prove that DP is equal to PQ is equal to BQ or QB. Got it? Okay. Now for this, you need to first prove that this quadrilateral is a parallelogram. You need to prove that this quadrilateral is a parallelogram. Okay, we'll see how to do that. You will also understand later why we had to prove AECF is a parallelogram. We'll understand that also later. Okay, now in quadrilateral, don't write AECF. Okay, AECF. AE is equal to CF because is AB equal to CD? Is AB equal to CD? Yes. Yeah. Why? Because ABCD is a parallelogram. Opposite sides are equal. So AB is equal to CD because ABCD is a parallelogram. So half of AB will be equal to half of CD because halves of equals are also equal. Okay. Now, since E is the midpoint of AB, what is half of AB? It can be AE or EB. AE or EB. Let's write AE. Half of CD. Because F is the midpoint of CD, half of CD is CF or FD. That's right, CF. So like this, you can show that AE is equal to CF. AE is equal to CF. C will come again. AB is equal to CD. Half of AB will be equal to half of CD. Half AB is AE or EB. Let's say AE equals half CD, CF or FD, CF. So like this, we have AE equals CF. Now, AB is parallel to CD. AB is parallel to CD. Why? Because ABCD is a parallelogram. Opposite sides are parallel. Now, what is CF? What is EB first? What is EB? What is AE? What is AE? It's a part of AB. AE is a part of AB. And what about CF? CF is a part of CD. So if AB is parallel to CD, then any part of AB will be parallel to any part of CD. AB is parallel to CD. Good evening. AB is parallel to CD. Good evening. AB is parallel to CD. Any part of AB. Okay, so let's say AE will be parallel to any part of CD, CF, right? So like this, we have AB is parallel to CF. AB, you can come closer, come here. Is the screen visible for you from there? Sure. You can read. You can read the screen. Okay. So like this, AE is parallel to CF. So what do we have? AE is equal to CF. AE is parallel to CF. Therefore, AECF is a parallelogram. Because in this quadrilateral, one pair of opposite sides are parallel and equal. So it's a parallelogram. Okay, now that we have proved it's a parallelogram, we have proved that this side is parallel to this side and this side is equal to this side. So AECF is a parallelogram. But now that it's a parallelogram, the other pair of opposite sides, AF and EC, they'll also be parallel and equal. Because now it's a parallelogram. So the other pair of opposite sides also will be parallel and equal. Okay, so now we have proved that this quadrilateral is a parallelogram. That's the first step. That's the first step. Now it's, this also is easy. Now what we're going to do is still easier. Now consider this triangle DQC. DQC. So how do we identify? How do I know I have to take this triangle DQC? See, we need to prove that DP is equal to PQ is equal to QB. We need to prove that DP is equal to PQ is equal to QB. So let's take a triangle that has these line segments DP and PQ, DP and PQ. So DQC. That way we choose DQC. See, the final result to be proved is DP equals PQ equals QB. Look at this part, DP equals PQ. We have DP here. We have PQ here. We have to show that DP is equal to PQ. So now we need to connect this in a triangle. So see, this is the triangle. This is the triangle. Now in this triangle, okay, in this triangle, F is the midpoint of CD, and through F, we have FP, which is parallel to CQ. Why FP is parallel to CQ? Because AECF is a parallelogram. Opposite sides are parallel. AECF, this one is a parallelogram. Opposite sides are parallel. So FP is parallel to CQ. So by converse of midpoint theorem, a line drawn through the midpoint of one side of a triangle parallel to the second side bisects the third side. So we have the first two conditions. What are the conditions? There should be a line through the midpoint of one side of a triangle. There should be a line through the midpoint of one side of a triangle. So F is the midpoint of CD. And through F, we have a line, FP, parallel to the second side, CQ. We have these conditions. So by the converse of midpoint theorem, P is the midpoint of DQ. P is the midpoint of DQ. So which means we have proved that DP is equal to PQ. We have proved DP is equal to PQ. Now we need to take another triangle where we have PQ and QB. Because we are going to show that A is equal to B and B is equal to C. So A is equal to B is equal to C. First part, we are going to prove A is equal to B. Second part, B is equal to C. Then both put together, A is equal to B is equal to C. So now we need to take a triangle that has PQ and QB. PQ and QB. PQ, PQ, QB. So see this triangle. PQ, QB. So this triangle. Again. Now, when you take this triangle, you also notice that we have this point E, which is the midpoint of AB. You need to take a triangle which has PQ and QB, and also the information which is given in the question. You need to take help of the information given in the question, right? So all put together, this is the triangle. See, when you take up this triangle, one is we have PQ and QB. The actual important thing is because we have the side AB where E is the midpoint. That's what we need to use the converse of midpoint theorem. Even in the first case, when we consider this triangle, why did we choose this triangle? Because we have DP and PQ. And I forgot to mention this. And also because we have F, which is the midpoint of DC. So together we choose this triangle. We have F, which is the midpoint of CD. And also we have this DP and PQ. So all put together, we choose this triangle DQC. Clear, Sachin? Okay. Now we need to take a triangle which has PQ and QB. PQ and QB. And the other information, we have already used F as the midpoint of CD. That we've used. But we haven't still used E is the midpoint of AB. E is the midpoint of AB. So see, E is the midpoint of AB. So both put together, we take this triangle ABP. Correct? Clear? Okay. Now use the converse of midpoint theorem. E is the midpoint of AB. Through the midpoint E, we have EQ parallel to AP. That's not given. But because AECF is a parallelogram, opposite sides are parallel. So EQ is parallel to AP. So a line through the midpoint E, parallel to the second side, bisects the third side. Therefore, Q is the midpoint of BP. If Q is the midpoint of BP, that means PQ is equal to QB. Earlier, we proved DP is equal to PQ. Now, PQ is equal to QB. So, put together, DP is equal to PQ is equal to QB. So, this proof is in a few steps. The first step is to prove that this quadrilateral is a parallelogram. Then step 2, we need to take up this triangle, use the converse of midpoint theorem, and prove that P is the midpoint of DQ. Step 3, take up this triangle, use the converse of midpoint theorem, and prove that Q is the midpoint of BP. In other words, PQ equals QB. Now, the result in step 2 and the result in step 3, together we get this result DP equals PQ is equal to QB, which means the diagonal BD is trisected. The diagonal BD is trisected. Yeah. Please write down. This part I've not, the proof ends here. I'll talk about, you write down this. I'll explain this later. Okay. This is not a part of this proof, but you just make a note of this. I'll tell you what it is. Good evening, Yarni.
Good evening, ma'am.
I've shared my screen. Visible, right?
Yes, ma'am.
Okay. Yes,
Yes.
Okay, so now coming to this part. Now supposing for the same information, the question is prove that dp is equal to 1/3 of db. Okay, so instead of saying show that, instead of this, prove that this information will be given and prove that dp is equal to 1/3 of db. dp is equal to 1/3 of db, or pq is equal to 1/3 of db, or qb is equal to 1/3 of db. It's the same, no? Correct. Each one is 1/3 of the whole thing. Yeah. So the question can be like this also. In that case, you will have to, use these steps to finish the answer. So after proving, okay, you should not write this. After proving dp equals pq equals qb, okay. So you have to do the proof till here, and after that, what is dp plus pq plus qb equal to db, right? dp plus pq plus qb is equal to db. Now, if they want you to prove that uh, bq is 1/3 of bd or db, what you should do? What is dp? It's bq. What is pq? It's bq. Okay, qb or bq, whatever. Okay, so bq, qb. So replace this also with bq because all these three are equal. We proved. So bq plus bq plus bq is equal to db. So 3 times bq is equal to db, or bq is equal to 1/3 of db. That is 3 comes for division, no? 1/3 of db. You're not able to see? She's in your way? Okay, just move your chair, no? Just adjust your chair. Now? Sure? Okay. Good for all of you, no? Okay. So this is what you'll have to do. We have to prove that dp equals pq equals qb, and after that, supposing we have to prove, now say dp equals 1/3 of db. So then what will you do? dp plus pq plus qb equals db. Now you need to get dp, right? So dp is dp plus pq is dp, and qb is also dp because all these three parts are equal. Equals db, right? So 3 times dp equals db, and dp is equals 1/3 of db. All right? Okay. Next one. Finish writing. Yes or no? No? No, no. Okay, complete now. Complete. Yeah, you need to take down that also. You completed? Take it. Okay. Okay. No, just write it in the same order. You will understand. Just put a box for this, so you will understand. If the question is to prove a dp equal to 1/3 bd, then you need to work like this. Yarni finished writing?
Yes, ma'am.
Divitra, Jayant, and Harsha, guess you were very late to join the meeting. Please join
Yes,
on time,
ma'am.
children. Yeah. Okay, so use the recording to understand that part of the class which you missed. Please use the recording. Go through the recording to understand the first half an hour or whatever you missed. Next one. Oh, you're still writing? Okay, okay. Finish. All right. Next one. ABC is a triangle, a right angle at C. So see here, ABC is a triangle. Okay, ABC is a triangle, right angle at C. A line through the midpoint M of the hypotenuse AB. Okay, this is the hypotenuse AB. This is the midpoint M of the hypotenuse ABC. Here, a line through the midpoint M of the hypotenuse AB. Okay, AB is a hypotenuse because it's opposite of the right angle C. M is the midpoint of AB is given. A line through that. Okay, a line through the midpoint M of the hypotenuse AB and parallel to BC. So that line, which comes through the midpoint M is parallel to BC. Is parallel to BC. Intersects AC at D. It meets AC. So this line travels like this. This line, from the midpoint M, it travels like this. It comes like this, and it meets AC in D. And this line is parallel to BC. All this is given to you. What is M? What is AB? Hypotenuse. 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 What about M? Midpoint of the hypotenuse. And what is MD? It's a line through the midpoint M. And it meets AC at D. And MD is parallel to CB or BC. All this is given. Okay. Show that D is the midpoint of AC. D is the midpoint of AC. So direct, no? Converse of midpoint theorem. See, in the triangle ABC, M is the midpoint of AB. MD is parallel to BC. This is enough, no? What's the midpoint theorem? What's the converse of the midpoint theorem? A line through the midpoint of one side of a triangle parallel to the second side bisects the third side. Do we have these two? Do you see a line through the midpoint of one side of a triangle? Yes. And is it parallel to the second side? Yes. So then it will bisect the third side by the theorem. Okay, so in the triangle ABC, M is the midpoint of AB, and through M, MD is parallel to BC. So this is what we need. If we have this, we can say by converse of midpoint theorem that D is the midpoint of AC. Therefore, by converse of midpoint theorem, D is the midpoint of AC. We proved this one. Next, you need to prove that MD is perpendicular to AC. MD is perpendicular to AC. That is MD. MD is perpendicular, meaning, see, this is MD, this is AC. See here, this is MD. This is AC. You need to prove that MD is perpendicular to AC. That means the two line segments, they meet at right angles. Perpendicular meaning the two line segments, they intersect at right angles or they meet at right angles. This is MD, this is AC. So you can see this is MD, this is AC. You must show that they are perpendicular to each other. So here 90 degrees. That's because they're corresponding angles. No, see your parallel lines, transversal. This is 90 because right triangle. So this is also 90. Corresponding angles are equal. Corresponding angles are equal. Parallel lines, transversal. This is 90 degrees, so this is also 90. Corresponding angles are equal. Why is this 90? Because it's a right triangle. Right angle at C. So MD is perpendicular. So because it's 90 degrees, that means MD is perpendicular to AC. Next, we'll have to prove that CM is equal to MA. We'll do it one by one. We'll have to prove CM is equal to MA. CM is this one, right? This is CM. CM is equal to MA is equal to MA. Oh, we have to show that this side is equal to this side. So that means we'll have to show that this triangle is congruent to this triangle. So then by CPCT, you can say MA is equal to MC. We'll have to show that CM is equal to MA. CM is equal to MA. So take up this triangle and this triangle. Show that they are congruent. Okay, show that they are congruent. See, this is the common side. And it's 90 here and 90 here. Correct? And then AD of this triangle is equal to CD of this triangle. Because D is the midpoint. No, we have proved D is the midpoint of AC. So by SAS rule, the two triangles are congruent. CPCT, you have MA is equal to MC. So we have proved MA is equal to MC. MA is equal to MC. But we'll also have to show that MA is equal to MC is equal to half AB. Is equal to half AB. Now, we already know MA is half AB, no? MA is half of AB. Why? Because M is the midpoint of AB. It's given. Yeah. See, M is the midpoint, right, of AB. That's given. See here. Midpoint M of hypotenuse AB. M is the midpoint. That means what? MA is equal to half of AB. Also MB. MB is also half of AB. So there's nothing to prove there. It's already given, right? So we already know MA is equal to half AB is given. MA is equal to half AB. Given meaning M is the midpoint of AB. So we know MA is equal to half of AB. And so this one we know MA is equal to half AB we know. And we've proved that MA is equal to CM. MA is equal to CM, we proved. MA is equal to CM, we proved congruency. So MA is equal to half AB, MA is equal to CM. This is by CPCT, and this is by the information given in the question. Now compare these two. MA is equal to half AB, MA is equal to CM. That means MA is equal to CM is equal to half AB. It's like A is equal to B and A is equal to C. That means A is equal to B is equal to C. So it means MA is equal to CM is equal to half AB. Just put some numbers. If this is 6, MA is 6. MA is 6, so this also is 6, right? If MA is 6, this also is 6. So see, everything is 6. All are equal. All right? It was a very simple proof. Please work out. Read the statement. As you write, please understand what you're writing. There is no hurry to complete. If you have any questions, you can ask me. Completed. Finished? Yeah. Yes, please. You're staring at me. You're frightening me. Yeah? Completed writing online, children? Yarni, Divitra, Jayant, and Harsha?
Ma'am, last 2 lines.
Okay. Oh, I thought you finished. You just finished, is it? You just finished? Okay. You were writing all the way? I didn't mark it properly. Okay. 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 Now, a few things we have to say here is when you draw the diagram itself, you will not know that you have to mark angle 1 and angle 2 here. You don't have to see, you have to draw the diagram as per the given information. That is triangle ABC. Look at the screen. Where are you seeing? Okay, so read the question and draw the diagram. How ABC, right angle, let's see. Right angle, let's see. Okay, so ABC is a triangle. All right. And then when you read M is the midpoint of AB. Okay, M is the midpoint. There's a line through M parallel to BC. Okay, and it intersects AC at D. Okay, D. That's all we can, that's all. So it's not that as soon as you draw this, you have to mark 1 here and 2 here. No, no. How will you know that you have to mark those angles as 1 and 2? Don't do that. Okay. So then you start working. You start working like this, right? As and when needed, you go back to the figure and mark. Because, writing angle DCB or ADM, when you revise, it becomes difficult. You'll have to every time check where is ADM, where is ACB and all that. When you use numbers to, represent angles, it becomes easy. Now, angle 1 is equal to angle 2 at a a quick glance, you can make out where is 1 and 2, and you understand the angles. But if you write angle ADM, angle ACB, every time you have to check where the angle is, right? That's the convenience. So when needed, you go there and mark 1 and 2. So here, this is converse of midpoint theorem. And then should I call this result A? As soon as you finish writing this, should you call this result A? No, you will not know that you'll have to call it A. How will you know? You will write, see, all this you will be writing. See, this you will write, given you will write, all this you will write. But how will you know that you have to mark this A? You will not. So don't, actually at this point, you will not be writing A here. Okay, this will not come when you write now. So now you want to say that CPCT, sorry, after this you want to say that these two lines are parallel, this is a transversal, so corresponding angles are equal. Now you want to mark. So come back to the figure and mark 1 and 2 and say angle 1 is equal to angle 2 corresponding angles. At this point, when you need to say they are corresponding angles and they are equal, come back to the figure and mark 1, 2. Angle 1 is equal to angle 2, corresponding angles are equal. Therefore, this ADM is equal to 90 degrees. It implies MD is equal to AC. Then I've marked 3, right? Here I've marked 3. I've marked 3 here. That only when you start this congruency proof, at this point you want to mention that this angle is equal to this angle is equal to 90 degrees. But you don't want to write MDA, MDC. You don't want to write MDA, MDC. So you mark in the figure 2 and 3 and say angle 2 is equal to angle 3, 90 degrees. So all those markings, 1, 2, 3 or anything, all that will be done in the figure when needed. And see, like as you proceed, here you write AD is equal to CD. But what's the reason? AD is equal to CD. What's the reason? Why is AD equal to CD? Because D is the midpoint of AC, right? D is the midpoint of AC. That's why AD is equal to CD. So at this point, because you want to say it's because of this, you go here, you mark this A and you say from A here. Now in this congruency proof, you're going to write AD is equal to CD. How do you know? How do you know AD is equal to CD? Because you've proved earlier. Where have you proved? So you come back to this line, you mark it A and you say from A. So when will you mark this A? When you come to this step here, when you come to this step, you'll come back here, you'll mark this A and you'll write here from A. How do we know AD is equal to CD? From A. Oh, where is A? This is A. What does A say? D is the midpoint of AC. Oh, D is the midpoint of AC. Yeah, so AD is equal to DC. And this B also. You will not know that you have to mark this B and this one C. You keep working. Then at this point, you want to say that from this result and this result. Because what is this result? What is this result? MA is equal to CM. And what about this MA is equal to half AB? So from this and this, we conclude that all the three are equal, right? So from this result and this result. So you go, since we've used A here, mark this B and C and say from B and C. So when you write this one, you will not be marking B here. When you write this, you will not be marking C here. After writing those two, then you will like tell yourself that, okay, now from these two results, we can get this result. So from these two results, right? So from this and this meaning, yeah, go back and mark this B, mark the C, and say from B and C. Always like this. Okay? Yes. Did I make some sense? All of you got it? Yes. Okay. Online children? Any questions?
No, ma'am.
Oh, all right. Okay, so when we started this exercise, we directly came to the, when we started this exercise 8.2, we did not do the examples before 8.2. Remember? I said we'll do the examples later. So we'll do the examples now. two examples we have, example 6 and 7. Okay, 6 and 7. 7 is simple, so I'll just present the proof. You have to read, understand, and you will explain this to me. It is simple. 6 will do together. Okay, 6 also. We'll discuss 6. Now I'll explain and we'll write and then we'll discuss and then we'll go to 7. Okay. So here we have a triangle. We have a triangle ABC. Triangle ABC. D is the midpoint of AB. E is the midpoint of BC. F is the midpoint of AC. Now these 3 points are connected. So now when you do this, the whole triangle is divided into 4 smaller triangles. The whole triangle ABC is divided into 4 smaller triangles. Here, triangle 1, triangle 2, triangle 3, triangle 4. The whole triangle is divided into 3 smaller triangles. You need to show that all these 4 triangles are congruent to each other. I said 4 smaller triangles. The whole, when you join the points D, E, and F, the whole triangle ABC is divided into 4 smaller triangles. We need to prove that these 4 triangles are congruent to each other. These 4 triangle 1, triangle 2, triangle 3, and triangle 4 are congruent to each other. All right? Congruent meaning identical. They are identical. So, which means if you have a chocolate in this shape, you have a chocolate in the shape of ABC, and you want to, divide this into 4 equal pieces, then just take a scale, mark the midpoint of this side, mark the midpoint of this side, mark the midpoint of this side, and cut it along this, and along this. You would have cut it into 4 equal pieces. You have a triangular chocolate. You need to cut that into 4 equal pieces. So what you will do? Just mark the midpoints of the 3 sides and cut it along those lines. Cut it along these lines like this. So now these 4 pieces are identical. Okay? Yeah. So how do you prove that they're congruent to each other? Now, the proof is very simple. Just see the
Want to prove all sides
which sides.
of AB, EF, AB, BD, EE, CE, CF, and AF.
No. You're saying like B and CF are equal, huh?
No, ma'am. And but remember there.
Yeah.
So we can say that they are sides. A, B,
Correct. That is DF is equal to B, you're saying. Correct. Yeah, you're right. Yes. All right. Yes, sit comfortably. Yeah. Put your pouch here and sit comfortably. Let's begin. Okay. So what you have to do is you'll have to prove that this one is a parallelogram. You'll have to prove that this is a parallelogram. When you prove it's a parallelogram, opposite angles are equal. Opposite angles are equal. And also, okay, 1 minute. Let's first prove that it's a parallelogram. Yeah. So in triangle, do you remember the midpoint theorem? What's the midpoint theorem? Yeah, I'll give you 2 minutes. Recall the statement of the midpoint theorem. Okay, you can look into your book also. Look into your book. Read it once and tell me.
The midpoint, two side, the one side is parallel, the point which connects the two sides of the triangle is parallel to the second side of the triangle and the bisects third side.
That is a converse of midpoint theorem.
Almost this two are parallel.
Correct. But read it clearly from your book. You've understood what it is, but you have to express it correctly, right? Yeah, look into your book. Midpoint theorem. Oh. Okay, I'll see if I have the statement here. This is a statement. The line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half of it. So we'll recall this before we see that proof. Triangle. In triangle PQR, if it is known that S is the midpoint of PQ, and if it is known that T is the midpoint of PR, then by midpoint theorem, ST is parallel to QR and ST is equal to half of QR. Okay, if you know the midpoints of any two sides of a triangle, then you can use the midpoint theorem. Okay? Yeah, I'll just give you 2 minutes because we're going to use this in the proof there. Recalled? So what should be given? Triangle with midpoints of any two sides. So the line segment joining the midpoints of any two sides of a triangle will be parallel to the third side and equal to half the length of the third side. All right? Okay. Okay. Yeah. So see here, we use in triangle ABC, we use the midpoint theorem, and the result is DF. DF is parallel to BC, and DF is equal to half of BC. All right. This is understood, right? Given is whatever is given, and what is to be proved. I've written here. What is to be proved? Okay. So first, in the whole triangle, D is the midpoint of AB, F is the midpoint of AC. So by midpoint theorem, DF is parallel to BC and DF is equal to half BC is what is here. Okay. Okay. Now in this quadrilateral, DFEB, in this quadrilateral DFEB, okay, in this quadrilateral, we can easily prove that one pair of opposite sides are parallel and equal. See here, this is parallel to this one and this is equal to this one. Why is DF equal to BE? Because DF is equal to half of BC, right? DF is equal to half BC, right? So DF is equal to what is half of BC? BE. Because E is the midpoint. See here, DF is equal to half of BC. What is half of BC? BE. BE. So what do we have? DF is equal to BE. DF is equal to BE. And what do we have here? DF is parallel to BC. So that means DF is parallel to any part of BC, right? So DF is parallel to BE. DF is parallel to BC or any part of BC. Any part of BC, BE. So DF is parallel to BE. So from these two results, that's what you see here. Because DF is parallel to BC, we have DF is parallel to BE. And because DF is half of BC, DF is half BC, DF is equal to what is half of BC? BE. BE. That's what you have here. So here what you see is in this quadrilateral, DFEB, okay, DF is parallel to BE for this reason and DF is equal to BE for this reason. These are proved here. Okay, so in the quadrilateral, one pair of opposite sides parallel and equal, therefore it's a parallelogram. All right. Now there's a property that says that the diagonal of a parallelogram divides it into two congruent triangles. Diagonal of a parallelogram divides it into two congruent triangles. Sorry. So the diagonal of a parallelogram divides the parallelogram into two congruent triangles. So if the area of the parallelogram is say 20 centimeters square, then it will be 10 centimeters square here, 10 centimeters square here. Because they're identical triangles. Identical triangles will have same area. Same, no, they look the same. So they'll have the same area. Diagonal of a parallelogram divides the parallelogram into two congruent triangles. And congruent triangles are equal in area. All triangles equal in area need not be congruent. Supposing there are two triangles, they have the same area. They need not be congruent. They need not be identical. There can be two triangles with the same area, but not identical. They have the same area, but they're not identical. They look, one is both are triangles, but different, shapes. Sizes, not shape. Shape is triangle only. Different sizes. Congruent triangles means identical triangles. Identical triangles means they have the same area. But when two triangles have the same area, they need not be identical. They have the same area, but they need not be identical. That's what it is. Okay. Diagonal of a parallelogram divides it into two congruent triangles. And congruent triangles are equal in area. So if the area of the parallelogram is 20 centimeters square, it will be 10 here. So here, diagonal DE, see here, diagonal DE divides the parallelogram. Diagonal DE divides the parallelogram into two congruent triangles. Therefore, this triangle is congruent to this triangle. All right? Yes, here. So the proof goes like this. We are going to show that triangle, okay, we are going to prove that triangle 1 is congruent to 2, triangle 2 is congruent to 3, triangle 3 is congruent to 4. So when you compare all this, all the 4 are congruent to each other. Like A is equal to B, B is equal to C, C is equal to D. So A is equal to B is equal to C is equal to D. 1 congruent to 2, 2 congruent to 3, 3 congruent to 4. So when you compare these results, sorry, when you compare these results, all the 4 triangles are congruent to each other. Okay, so we proved that this one is a parallelogram. The diagonal divides it into two congruent triangles. Therefore, this triangle is congruent to this triangle. Now prove that this one is a parallelogram. This one is a parallelogram. Okay, so then you can, once you prove this is a parallelogram, this diagonal divides it into two congruent triangles. So then triangle 1 is congruent to triangle, what is this? Some 3 or whatever. Okay, whatever. All right. Then prove that this one is a parallelogram. This one is a parallelogram. So you'll get this triangle is congruent to this triangle. So 1 congruent to 2. Okay, here it is 1 congruent to 2, 1 congruent to 3, 1 congruent to 4. 1 congruent to 2, 1 congruent to 4, 1 congruent to 3. This also, like in some cases, it will be like as I just explained, 1 congruent to 2, 2 is congruent to 3, and 3 is congruent. This way also, all the 4 are congruent to each other. But here, since there's a common triangle, this one is a triangle common, okay, to all the parallelograms. In this parallelogram also, you have this triangle. In this parallelogram, you have this triangle. In this parallelogram also, you have this triangle. So here what we get is 1 is congruent to 2, 1 is congruent to 3, and 1 is congruent to 4. Which are the 4 parallelograms? Which are the 3 parallelograms? This is one. This is a quadrilateral, which we have to prove is a parallelogram. This one is a quadrilateral, which we have to prove is a parallelogram. This one is a quadrilateral, which we have to prove is a parallelogram. Okay. Now, how do we show that this one is a parallelogram? This one. We'll have to again show that this is parallel to this and this is equal to this. So it's a parallelogram. All right. And now that's a parallelogram. This triangle is congruent to this triangle. 1 is congruent to 3 because the diagonal divides it into 2 congruent triangles. Then show that this is a parallelogram. This one is a parallelogram. So you will get, if this is a parallelogram, this is the diagonal. This is the diagonal. 2 congruent triangles. 1 is congruent to 4. So how do you show that this is a parallelogram? You can either show that this is parallel to this and this is equal to this, or you can show that this is parallel to this and this is equal to this. Anything. Everywhere we prove that one pair of opposite sides parallel and equal, so it's a parallelogram. So we'll have to prove 3 parallelograms here. We have 3 quadrilaterals. We'll have to prove that those 3 quadrilaterals are parallelograms. And then use the property diagonal divides it into 2 congruent triangles. Okay, I'll just tell you the steps again. Okay, so first midpoint theorem. First is midpoint theorem. So we get the result DF is parallel to BC and DF is equal to half BC. With the help of this, we are able to show that this one is a parallelogram and also this is a parallelogram with the help of this result. Midpoint theorem results, we are able to show that these two are parallelograms. So then once you say that this is a parallelogram, D is the diagonal. So triangle 1 is congruent to triangle 2. Then we have proved that this one is a parallelogram. This is the diagonal. So triangle 1 is congruent to triangle 3. Then you see the proof, take the help of the proof and understand. You'll have to prove that this is a parallelogram. For this, you need to do something. You'll see the in the proof there. So you'll have to prove this is the parallelogram and this is the diagonal. So divide it into 2 congruent triangles. So triangle 1 is congruent to triangle 4. So 1 is congruent to 2, 1 is congruent to 3, 1 is congruent to 4, which means all 1, 2, 3, 4 are congruent to each other. Okay, so see here. Show that triangle ABC is divided into 4 congruent triangles by joining D union. All right. As you write, please understand. We have to use the midpoint theorem again here to show that this one is a parallelogram. So you can understand. Do it. Work mindfully. I'll give you 15 minutes. Read, understand, write down carefully. Done writing here, all of you?
Yes, please.
Okay. Online
Yes.
children?
Yes, ma'am.
Okay. Jayant is there, Harsha, Gayatri, Arni. Somebody's left the meeting. Who's that? Hey, Harsha, Jayant, Arni. There was one more person, no? Oh, Devitra. Devitra. Understood, no? The proofs? Shreya? Understood the proof?
Yes. Understood, please.
Okay. Okay, we'll start with
Oh, no.
huh? What did you say?
Example 7.
We'll start with Sanjay. Yeah. Sanjay. How do you begin?
The DBEF is a parallelogram.
Okay. So first midpoint theorem.
Is
Yeah. D is the midpoint of
D is midpoint of AB.
in triangle ABC. D is the midpoint of
AB.
okay. F is the midpoint of
F is midpoint of AC.
okay. So by midpoint theorem,
By midpoint M, DF is equal to half of BC.
DF is equal to half BC and DF is parallel to BC. DF is parallel to BC and DF is equal to half BC. Okay. By midpoint theorem, DF is parallel to BC and DF is equal to half of BC. Okay, so DF is parallel to BC also implies DF is parallel to BE. And also DF is parallel to EC. EC. DF is parallel to BC means DF is parallel to BE, DF is parallel to EC. And DF is half BC. What is half of BC? BE, EC. BE, EC. So that means DF is equal to BE and DF is equal to EC. Let me write it like this 1 minute. By midpoint theorem, we have by midpoint theorem, we have DF is parallel to BC and DF is equal to half BC. This one means DF is parallel to BE and DF is parallel to EC. And this one means DF is equal to BE, DF is equal to EC. Now look at these two. DF is parallel to BE, DF is equal to BE. So which is a parallelogram? DFEB is a parallelogram. And DF is parallel to EC, DF is equal to EC. Which one is a parallelogram? DFCE is a parallelogram. DFCE is a parallelogram. Isn't it simple? Isn't it simple? So these results we get by midpoint theorem. This means these two, and this means these two. So when you take these two results, this one is a parallelogram because one pair of opposite sides parallel and equal. When you take these two results, DF and EC, DF, EC, DF is parallel to EC and DF is equal to EC. DEF, CF is a parallelogram. And then to prove that this is a parallelogram, ADEF. To prove that this is a parallelogram, we need to again use a midpoint theorem. And so there you will get DE is parallel to AC, and that is, you should say D is the midpoint of AB, E is the midpoint of BC. Therefore, DE is parallel to AC, and DE is equal to half of AC. So D is DE is half AC, means DE is equal to AF. And DE is parallel to AC, means DE is parallel to AF. So this is a parallelogram. So now we have proved 3 parallelograms, right? In this one, this is a diagonal. So these 2 triangles are congruent to each other. In this parallelogram, this is the diagonal. So these 2 triangles are congruent to each other. In this parallelogram, this is the diagonal. So these 2 triangles are congruent to each other. So this is a common triangle. The one in the middle is a common triangle, and that is congruent to all the other 3 triangles. So all the 4 triangles are congruent to one another. Remember the proof like a story. So when you see this question or the statement, you should understand you should recall the sequence of the proof. That is to prove that these 3 are parallelograms, and use the property that the diagonal divides the parallelogram into 2 congruent triangles. That's how we do this. Any questions, online children?
No, ma'am. No, ma'am.
Okay. Yeah. Yeah, please help yourself. Oh, intercept. Yeah, good. Very good. What is an intercept? Intercept is a portion of the transversal between 2 parallel lines. Intercept is a portion of the transversal between 2 parallel lines. Now see here, this line is parallel to this line. This is a transversal. This one is an intercept because this is the piece of the transversal between these 2 parallel lines. A piece of the transversal between 2 parallel lines is an intercept. Intercept is a line segment. Okay, so here, see, this line is parallel to this line, right? This is a transversal. Now, this one is an intercept. AB is an intercept. BC is an intercept. DE is an intercept. EF is an intercept. Correct? Which are the intercepts? AB is an intercept. BC is an intercept. DE is an intercept. EF is an intercept. These are intercepts are parts of meaning pieces of the transversal between the 2 parallel lines. Yeah. Yeah. Oh, you're still writing? Okay. What you were talking? Yeah, then what? So they've all finished writing. You're going through the proof. Okay. Yeah. Yeah. So how do we do this? What is given? L, M, and N are three parallel lines intersected by two transversals P and Q. L, M, N are three parallel lines intersected by two transversals P and Q. Now it's given that L, M, and N, they cut off equal intercepts on P. They cut off equal intercepts on P, meaning what are the intercepts on P? AB and BC. AB and BC are the intercepts on P. They cut off equal intercepts. That means AB is equal to BC. You need to prove that L, M, and N also cut off equal intercepts on the transversal Q. This is the transversal Q. Yeah, DE is equal to EF. DE and EF are the intercepts on the other transversal Q. Given that AB Given AB is equal to BC, you must prove that DE is equal to EF. Which are the intercepts on the transversal P? Intercepts on transversal P, AB and BC. Which are the intercepts on transversal Q? DE and EF. Correct. DE and EF. What is given equal? AB is equal to BC. The intercepts on the transversal P are equal. AB is equal to BC. What should you prove? DE is equal to EF. That is the intercepts Q. Yeah, the intercepts on the transversal Q are also equal. Correct? What's the construction? Join AF. Join AF. When you join AF, you get two triangles, right? Meaning triangles ACF and ADF. ACF and ADF. We get two triangles. When you join AF, sorry. When you join AF, you get two triangles. Okay. Who wants to try online? In triangle ACF,
Mom, D is the midpoint because AB is equal to CB.
correct. AB is equal to BC. So B is the midpoint of AC. B is the midpoint of AC. Then Gayatri next. Mark this one. G. Call this G. Okay. Call this D. Then
So then BC will be parallel to CF.
BG is parallel to
CF because M and N are parallel.
correct. Because M is parallel to N, BG is parallel to CF. Any part of M will be parallel to any part of N because M is parallel to N. M is parallel to N. So BE is a part of M. CF is a part of N. So because M is parallel to N, B is parallel to CF. Then, so what are we using here? The converse of midpoint theorem, right? Sorry, BG we must say. I said BE, BG. BG is parallel to CF. So by the converse of midpoint theorem, G is the midpoint of AF. I said wrong. No, I'm sorry. Okay, so construction join AF. And when you join AF, let it intersect B at G. So I mark this point G. So in triangle ACF, B is the midpoint of AC. And through the midpoint B, we have BG parallel to CF. Why? Because M is parallel to N. BG is a part of M. See that BG, it's a part of M. And CF is a part of N. Because M is parallel to N, any part of M will be parallel to any part of N. So BG is parallel to CF. Therefore, by converse of midpoint theorem, G is the midpoint of AF. Now in triangle ADF. No, first midpoint. G is the midpoint of
G is the midpoint of AG and GF.
G is the midpoint of AF. See, which are the three sides of the triangle? AF, FD and AD. Yeah. G is the midpoint of AF, then through the midpoint G. G is parallel to AD. G is parallel to AD. Correct. Why? M is parallel to L. M is parallel to L. A part of M is GE. A part of L is AD. G is parallel to AD. A line through the midpoint G. GE is parallel to AD. Therefore, by converse of midpoint theorem, by converse of midpoint theorem, E is the midpoint of DF. So if E is the midpoint of DF, it means E is, yeah, correct. If E is the midpoint, if E is the midpoint of DF, that means DE is equal to EF, which means the intercepts on the transversal Q are also equal. All right? So for midpoint theorem, what triangle ABC, if it is given that D is the midpoint of AB and E is the midpoint of AC, then by midpoint theorem, DE is parallel to BC and DE is equal to half BC. This is midpoint theorem. Converse of midpoint theorem is in triangle ABC, we only know one midpoint. D is the midpoint of AB. Through the midpoint D, there is a line parallel to the second side BC. So this is given. D is the midpoint of AB given. And this line is parallel to the second side BC is given. Let's say that this line meets the third side at E. D midpoint of AB, DE parallel to BC given. Then the result by the converse of midpoint theorem is E is the midpoint of AC. E is the midpoint of AC. All right? Any questions? Yarni, Jayant, Gayatri, and Harsha?
No, ma'am.
Okay.
No doubts.
Okay. Jayant, you alone stay back because I just need to check why you're taking online classes. Please stay back.
Okay.
Yeah. Thank you, children. So that's it for today's session. Thank you so much. You may leave the call, online children.
Thank you, ma'am.
Thank you. Thank you, children.
Thank you.